YouTube, vSecure here. Today I wanted to talk about access lists. Now, in the first few videos, we started about talking about separating networks using VLANs. And then the next few videos we started about working on creating routes or ways to get traffic between those VLANs, using route around a stick or SVIs and even routed interfaces with basic static routing. Now, if we did all that work, why did we even separate the network traffic to begin with? Well, there are a few reasons. One of the reasons is separate networks create, a new broadcast domain, or it helps with management of the network, being able to separate, if it's in a closet. Now, broadcast domain is a new word. It's that I've used. It's exactly what it sounds like. It's how far a broadcast packet will go inside your network. So, in one VLAN, a broadcast will stay inside that VLAN. So these broadcast domains need to remain relatively small, or a lot of traffic can be wasted as broadcast traffic, as broadcast traffic can chew up bandwidth on ports if a lot of devices are connected on a single network. Now, the largest network I've seen would probably be like a /21, which is a very large network because that can contain up to 2,000 endpoints on that VLAN. Generally, you're going to see probably a /24 or /23, about 250 to 500 devices, and that's more preferred. Now, that may help explain, the VLAN separation, but then is there a way to separate things if it is between different VLANs? Well, that answer is obviously yes. It's using an access list. So there are a few different types of access lists. There's routed access lists, or RACLs, port access lists, PACLs, or even VLAN access lists, VACLs. So we'll mostly focus on the more common type of ACLs you'll see, and that's routed and port varieties. What an ACL does, it will either match on the source traffic and permit or deny it. It's called a standard, or match on source and or destination traffic, extended. And these extendeds can even match on, the TCP or UDP port. Now, a routed ACL is used on a routed interface. A port ACL is used on the common endpoint port, and a VLAN ACL is used to filter traffic in the same VLAN. So to start, we're going to create a standard ACL to block traffic from our host on PC1 from communicating with a host at PC7. So here's the diagram of our network that we're going to be using. So for this example, since we are starting with a standard ACL, there are two ways of doing it. We can use a numbered ACL or a named ACL. We're going to start with a numbered one. So let's get our switch here. We're going to go into global configuration mode. And the command to create an access list, a standard ACL, is access list. The number, we're going to use number 1, deny host, and the host is, let's just double check the host IP, 10.10.10.2. Deny host 10.10.10.2. Now, with all access lists, there's an implicit deny all command at the end. So if we left this configuration this way, all traffic would be blocked, which we don't want. So we need to add another entry into this ACL, and that is access list 1 permit any. Now, that command will deny anything from a source host IP of 10.10.10.2. So now we need to place that routed ACL. Now the best option is to put it as close to the source of the traffic as possible. So the place that we are going to put this on is our routed interface between these two switches. So that is interface ET30. So the last thing we need to decide is in what direction we will block on the port. Is it going to be going in or out of the port? In our case, we want to block the traffic going out our interface. So that command is IP access group 1, because this has to match this here, and then the direction out. That's it. Now to verify that we're blocking PC1 from connecting to PC7, let's try pinging it. PC7's IP is 10.10.30.2, so let's try pinging that. We can't get there. Okay, so let's make sure we didn't block the rest of our network from getting there. So we'll hop on PC2, and we should see that this is not the same IP. So let's see if we can get to 10.10.30.2. And this one is working. So now if we needed to troubleshoot some of our ACLs, if we're having some issues, we can use the command show access list, and this gives us a hit count. We can see we're being denied from ours, but we're permitting other traffic. Now, this will allow users to see if the rule is getting hit or it's being skipped. Now, the best way I've seen to find out which interfaces may have an ACL on it, and there might be a better way, but this is the one that I've used, is show IP interface, pipe include line or list. So as you can see right here, it's showing that there is an outgoing access list applied, and it's number 1. So you could do show access list 1, and you'd see just that. Now, this is how we can see if it's also implied inbound or outbound. Now, a thing to take note for future reference, a port ACL can only be enabled inbound on that port. So we'll do a similar configuration as earlier, but now allow our PC3 not to communicate with PC7 using a named ACL this time. So the global configuration for a named, we have to go to global config mode, and then it's IP access list standard, and then the name, I'm going to do block PC3. And now we're in a substandard named ACL mode, standard named ACL. So let's just get what PC3's IP is. And it's 10.10.10.3. So then we're going to do deny host. And now here you could do many different choices. You could do host, any. Okay, so you can't do many. But you can do host, or just put in the IP address, or any. So I'm going to do host 10.10.10.3. And then finally permit any. And again, this is to allow us to allow all other traffic to go. And then we're going to apply it to the interface. This is the same as last one. And it's IP access group block PC3 out. So again, now we can verify that PC3 cannot connect to PC7. And again, it's not working. Let's hop on PC4 to verify he still can. Ping 10.10.30.2. And that one is still working. And again, we can use all the same commands as before. Show access list. Show interface. Pipe include. List. Line. I'm sure. Let's show IP interface. And here we can see again. And you can only apply one ACL on an interface. So this did remove the standard numbered ACL. So just make note of that as well. Alright, now an extended access list. Now, extended access lists adds features onto the standard ACL. Like I said, most notably being able to use the source and destination IPs and, TCP UDP ports. Therefore, the format is a bit different. They do both support numbered and named as standard, with numbering starting at 100. The format of an extended ACL is first permit or deny, then with a protocol to match on, if it's IP, TCP, UDP, EIGRP, OSPF, etc. And then the source of the traffic, and then optionally the port, and then finally the destination of the traffic, and optionally the port. So if we then want to create a rule to say where maybe PC7 cannot ping PC1, but can ping everything else, this is the command that we'll need to enter. So let's hop on switch 4, go into global config mode. And we're going to do IP access list extended. Now again, I said we could use a number or name. I generally prefer using names just because it gives a description. Oh no, we're trying to block to PC1. Alright. And then we're going to deny ICMP because it's just ping from our host, which is 10.10.30.2, to another host, which was PC1, which is 10.10.2. We're going to permit all other traffic. So we're going to then do permit IP, because that's anything, any. Alright, now we can apply this access list to the interface that PC7 is connected to. And that should be interface ET00. So we're going to go there and do IP access group. And here we do the number of the name. And the name is block ICMP PC1. And then, of course, we have to give it the direction. And since this is a port ACL, we can only do it inbound. So in. And now we can test that. Let's try pinging 10.10.10.2. Let's me make sure that that's the right interface. Yeah, Ethernet 00. So let's do a little bit of troubleshooting. Why is this not? Make sure there's no typo anywhere. Show access list. I wonder if there is a limitation on IOL. I'll do a little bit of research, but to show that this does work, we'll put it on the routed interface. Interface ET30 IP access group block ICMP PC1 in. And now we'll try and make sure I didn't typo. Deny ICMP from 10.10.2 to 10.10.10.2. I'm not quite sure why we're not matching on ICMP. I see it hitting IP. And now these could be some limitations on IOL. I will have to do a little bit more testing. But what we can do is go back to our named ACL. Let me go back into global configuration mode. Go back into ICMP, PC1. And then we're going to do... So if you want to make a modification to a line entry, we can actually type in the number. Deny IP host to host. Oh. Sorry, we have to remove it, and then we can re-add it. So now we can do a show access list, and we should be able to see it. Yep, and now it switched from ICMP to IP. Alright, let's try this one more time. Well, I'm not quite sure why we're not matching on it. Let's see for... I know I've tested this before and it's worked. Do show IP interface. Include line list. Alright, it is there and there. That's our IP, 10.10.30.2. Well, that's 10.10.10.2. This shouldn't do it, but let's try this. So you notice how I used 15. That was just to make sure it would fall in between these two. So we can try one more time. Oops. Well, that one is matching. I wonder if... Let's see if I could ping... That one's matching as well. Alright, so it should be source destination, so that's why well, I guess we learned that this one prefers source destination like that. It's very interesting. Okay. Well, it was good troubleshooting. This is what you might have to do, when you're working. Alright. So we did some testing, we did some pings, did some show commands to try to do this troubleshooting. Let's quickly cover VLAN access lists. Now this I won't be able to show because it's a limitation on the iOS where I can't actually use these commands. But a VLAN ACL, a VACL, will block traffic within the same VLAN. So if we want to stop traffic from one host to another host, we have to match on that traffic we want to block, which means a permit statement, which does sound a little confusing. So say it's something like IP access list extended block permit IP any host. Now that we matched on traffic, we can create that VLAN access map. Now that command is VLAN access map and then the name, so like block, and then a number, like what sequence it's going to be in. So you could do like 10. You're going to do match IP address, and then the IP address we just created in the top one, block, and then the action drop. So I can kind of show that a little bit. We could do IP access list extended block permit IP any to host, So we want to block this traffic. So we're going to match on anything going to this host. And then you'd use these commands, which unfortunately, like I said, I can't show. VLAN access map, the name of what we want to call it. This doesn't have to match up here. And then number. This is similar to route maps, but I'm not going to cover that yet. See, the command doesn't work here. But then inside here, we'd match an IP address, and then we use the name of our access list we created up here. So it would be block. So then you'd match that, and then you'd tell it an action, and we'd drop it. And then to make sure that only that traffic is dropped and everything else is passed, we'd have to do VLAN access map block 20 in the next sequence, and then the action would just be forward. So I know that looks funky because I couldn't type it out, but this would match on all traffic that we put in our extended ACL. We'd drop that and we'd permit everything else. That's why we need that VLAN access map block 20 command to pass the other traffic. Now, once the access map is created, we need to use a VLAN filter to filter the traffic on that VLAN. And that command is VLAN filter, the name of our access map, which is block, and then the VLAN list, and that's just to tell it what VLANs to apply it to. So let's say it was VLAN 10. Now that one's definitely, I've always found VACLs to be the most confusing. But yeah, those are the commands. Unfortunately, like I said, since IOL has some limitations, I can't show that. But thanks for sticking around. I know this has been a lot. In the next video, we're going to go back to some basic common configurations that should be made on switches for basic access to like putting a host name on the switch. Thanks for sticking around, and I'll see you next week.